Good afternoon on today's Angry Bulletin. Even though the Cassini mission to Saturn ended over 6 years ago, the data is continuing to roll in. And in a shocking discovery, NASA scientists have found even more evidence of life beneath the icy surface of Enceladus, suggesting that life may exist beneath the surface of a wide variety of moons, as long as you have liquid water, as long as you have the necessary energy, and as long as you have the organic compounds, you can have life. And Enceladus has all of these and a lot more than that. All of this and more coming at you on the Angry Astronaut right now. Good afternoon, and once again, welcome to the Angry Astronaut. Once again, just want to make sure that everybody is aware that my content has taken sort of a different approach lately. In order to keep the daily content rolling, I now have a series that's called Angry Clips, which is relatively short videos that still have some very interesting information from the world of spaceflight and space science, and the one that I released yesterday about the James Webb Space Telescope, and boy, some incredible things that it's been uncovering lately. Well, probably my least viewed video in the last 4 years. I think people are just assuming if it's not similar to what they're used to seeing from me, then it's going to suck. But I'll tell you, from the comments that I got on that video, people are really enjoying what they're seeing from these clips. They're very informative and have some pretty unique information. So I hope you guys give those clips a chance here in the future. Okay, that's enough talk about that. Let's talk about the topic at hand. So you guys probably have been hearing some interesting news about Enceladus lately, and that news is getting more and more interesting all the time. Even though our last mission to Saturn actually ended some time ago, we're still examining the data in great detail, and more fascinating information is coming to light. And with every new discovery we make, it seems more and more likely that life exists beneath the ice on Enceladus, and not just there, also on the moon of Titan, both on the surface and also beneath the surface. Scientists are beginning to suspect that there may be something there as well. And what I have long believed, and I think what we're going to find to be true as time goes on, is that life is almost as universal as gravity. The spark of life manifests wherever it is possible for it to manifest. We see life spring up in a wide variety of environments far outside what is technically the habitable zone of our star. We've made so little effort to actually detect life in our solar system, and I think that once we actually once we carry out experiments that are more ambitious than the ones that we've carried out thus far, we are going to find conclusive evidence that life not only exists beneath the ice of Enceladus, but all over the cosmos. Mankind has been obsessed with Saturn and its moons since Galileo first observed the planet in all its glory in the early 17th century, and although he didn't have the best idea as to what the planet looked like or why it looked the way it did, he did at least capture the rings, even though he didn't fully understand what they were. At first he thought they were moons orbiting very close to the planet. Later on he thought they were arms of some kind. But in fact, they turned out to be something even more magnificent than Galileo ever thought. But interestingly enough, the most fascinating thing about Saturn, at least for those who are interested in finding extraterrestrial life, are not found in the rings or even on the planet itself, but rather with its moon. Now, at first, everybody thought that the most interesting moon in the Saturnian system was Titan, because we knew that Titan had an an atmosphere, and we strongly suspected that Titan also had liquid at its surface. Not liquid water, of course, but rather lakes made out of liquid methane, and consequently, the vast majority of the scientific instruments designed to detect things like atmospheric composition, organic compounds, that sort of thing, were actually located on the Huygens lander designed to set down on the surface of Titan, which it did spectacularly. However, there weren't a whole lot of instruments on the Cassini orbiter that were well disposed to detect organic compounds or any other signs of life. But of course, nobody really expected to find any sort of signs of life except in the atmosphere or on the surface of Titan. However, shortly after Cassini arrived in the Saturnian system, it began to see strange things indeed coming from Enceladus. Plumes of what appeared to be ice crystals gushing forth from the south pole of the moon like some sort of strange ice cano. This is a sort of phenomenon that we had seen before in the solar system. In fact, the first example of cryovolcanism was found in 1989 when Voyager 2 flew past Neptune's moon Triton and saw a plume of water rising 8 kilometers above the surface. It was then that we knew that these moons had liquid water beneath their surface. Perhaps all of them had liquid water beneath their surface, made liquid by something called gravitational tidal forces. In other words, the powerful gravitational pull of nearby gas giants, or even sometimes large moons, create powerful tidal forces inside the moon, similar to oceans in motion, that can therefore make the water liquid. And when water becomes liquid, things start to get very, very interesting. But of course, the question arose, how the hell are we going to find out what's happening inside the moon of Enceladus when we didn't equip Cassini with some sort of lander to set down on the ice? Or indeed, how would we find out what's happening beneath the ice of Enceladus with a simple little lander that would probably be incapable of drilling through it? And this, by the way, is something that really irritates me, because we had lots of reasons to believe that moons like Enceladus might have subsurface oceans, and we didn't put anything on the Cassini orbiter that was even capable of picking up the spectrographic telltale signs of the types of elements that would be associated with life. They might have been on the Huygens lander, but not on the orbiter. The orbiter was almost exclusively designed to study Saturn's magnetic field, its rings, that sort of thing, and not look for life. And by the way, this is a commonplace problem with NASA's missions to the planets. Very seldom do they include any sort of experiments that are designed to detect signs of life. Why? I can't begin to imagine. Probably because when the Viking mission in 1976 detected very solid evidence of bacterial life existing in the regolith, there was so much controversy over the issue that in the end, the evidence was regarded as being inconclusive, because extraordinary claims require extraordinary proof. And since these sorts of probes are unlikely to ever be able to gather extraordinary proof, they're not designed to gather any damn proof at all. However, undeterred, the NASA researchers decided to try to pound a square peg into a round hole and use the instruments that Cassini was equipped with to study the plume as best they could. Now, frustratingly, the instrument that they used was only designed to detect various levels of hydrogen in the plumes and the general structure of the eruptions. That doesn't provide direct evidence of the elements that might be in these plumes, but by studying the patterns and by studying the general disposition and the appearance of the hydrogen, because a lot of the hydrogen was bonded together with other elements, or so the researchers believe, in time they were able to deduce what other types of elements might also have existed inside the plumes. And these elements proved to be interesting indeed. How much more could we have found out if we had had a real chemical sniffer on the Cassini probe? But nevertheless, the researchers did the best they could, diving the Cassini probe daringly through the plume, not knowing if it would survive the experience, in 2015. And after a couple of years of study, in 2017, scientists found their first evidence that Enceladus might have chemistry that would sustain life. The combination of carbon dioxide, methane, and hydrogen in the plume was suggestive of a process called methanogenesis, a process that produces methane. In general, here on Earth, methane is only produced by this process by life-sustaining activity or by some sort of volcanism. Now, conventional volcanism does not exist on Enceladus, again, strongly indicating that there might be a life-producing process that's giving rise to this type of chemical, but we have found a lot more since then. At the beginning of this year, phosphorus, the least abundant of the essential elements necessary for biological processes, was detected in the ice crystals ejected by the plume, or at least, according to the research, that's what the evidence suggests. Quote, "We previously found that Enceladus's ocean is rich in a variety of organic compounds," said Frank Postberg, a planetary scientist at the Freie Universität in Berlin, Germany, probably mispronounced that, who led a new study, again, that was published on Wednesday, June the 14th, in the journal Nature. He goes on to say, quote, "But now this new result reveals the clear chemical signature of substantial amounts of phosphorus salts inside icy particles ejected into space by the small moon's plume. It is the first time this essential element has been discovered in an ocean beyond Earth." And now, over 8 years later, in a study that was published a mere 2 days ago on December 14th, 2023, another team of researchers found a bumper crop of organic molecules, most significant of which is hydrogen cyanide. They also uncovered evidence that the ocean holds a powerful source of chemical energy. Unidentified until now, the energy source is in the form of several different organic compounds which serve as fuel for living organisms. This indicates that there's far more chemical energy inside Enceladus than we previously thought. Jonah Peter, the lead author of the study at the JPL, had this to say, quote, "Our work provides further evidence that Enceladus is host to some of the most important molecules for both creating the building blocks of life and for sustaining that life through metabolic reactions. Not only does Enceladus seem to meet the basic requirements for habitability, but now we have an idea about how complex biomolecules could form there and what sort of chemical pathways might be involved." Keep in mind, guys, this is not just bacterial life. Sure, that might be the only thing that exists in the oceans of Enceladus, but there's every reason to think that we might have complex, multicellular life existing beneath the ice of Enceladus as well. Perhaps even more complicated than the life of our own oceans, because keep in mind, as near as we can tell, all of this liquid water, far more liquid water than there are in all of the oceans of our planet combined. Plus, all of this chemical energy has existed beneath the ice of Enceladus for billions of years. Lots of time for complex life to develop, and it may be a lot more bizarre than the sea monster images you're looking at right now. Something that evolved in a completely different environment and on a completely different world might be more bizarre than anything that artists can possibly imagine. And the data is still being analyzed. According to Tom Nordheim, a JPL planetary scientist who's also a co-author of the study, had this to say, quote, "Our study demonstrates that while Cassini's mission has ended, its observations continue to provide us with new insights about Saturn and its moons, including the enigmatic Enceladus." And what you're looking at right now is a proposed mission to land on the surface of Enceladus, drill through the ice, and find solid evidence for the existence of life once and for all in the solar system. But as you can probably imagine, this is a mission that is unlikely to happen anytime soon because of a lack of funding. Had NASA simply planned for this to begin with, and as I said before, there was definitely a reason to believe that they might detect ice canos in the Saturnian system, given the fact that we had seen them orbiting other planets in 1989, we might not be debating the existence of life in the solar system, but instead studying it in detail right now. But this isn't the only moon in the Saturnian system to have the telltale signs of life. On the surface of Titan, in 2005, a pair of astrobiologists predicted that organisms living in the liquid methane on Titan's surface would produce strange depletions of hydrogen, acetylene, and ethane as they consumed these substances. And years later, both the Huygens lander and recent Cassini data provide intriguing evidence for such depletions. First of all, photochemical modeling of the surface revealed that there is an unexpected lack of ethane on the surface, as they predicted, and also that hydrogen concentration, this was in 2010, was discovered to be strangely absent as well, and the observational data is best explained by a strong flux of hydrogen into the surface, which can only be created, at least the best explanation for why this is happening, is the metabolism of hydrogen by methanogenic organisms. And then finally, a third study reported an apparent depletion of acetylene at the surface compared to the expected rates of atmospheric production and subsequent deposition of acetylene onto the surface. There is no evidence of acetylene in the gases released from the surface after the Huygens probe landed. And this depletion also is exactly what these exobiologists predicted would happen if there were widespread methanogenic life forms on the surface or living in the methane lakes. All of this is intriguing in the extreme, and combine that with the fact that Titan most probably has a liquid water ocean beneath its surface, you could actually have two fundamentally different types of life forms evolving on the same moon. I'd like to thank my latest Patreon supporters, Dan, Doc Midnight, and Barry McMillan, and on top of that, I would also like to thank Michael Maxey for bumping up your membership on Patreon. It's because of people like you that I can keep this content coming. Please like, please subscribe, and as always, stay angry about space.